Things in space don't spontaneously speed up on their own. This mysterious comet is getting power from somewhere. Right now, the scientific community is in total disarray. Some people say that our tools aren't working right. People are uttering things that no one wants to hear. This isn't normal. We're not alone, and whatever sent this is keeping an eye on us right now. You will be scared of what occurs next. The figures alone are mind-blowing. This thing is going faster than 130,000 miles per hour. This thing is so fast that, if you could somehow get a ride on it, you could get from New York to Los Angeles in just over a minute. That's faster than anything people have ever made. Voyager 1, our fastest spacecraft, has been traveling for decades and is already in interstellar space. It goes about 38,000 miles per hour. This person is moving at least 3 times quicker than that. NASA scientists validated what many people in the astronomy community had suspected but were too scared to declare out loud within a day of finding it. The thing didn't come from anywhere in our solar system. It had come from a place very far away, across distances so great that light itself takes years to cross them. There was no doubt about the computations. 3I Atlas had journeyed through the icy space between star systems, which probably took hundreds or perhaps millions of years to accomplish. Our sun, which is quite big and has a strong gravitational pull, can't catch this guest, which makes it even more amazing. Most things that come into our solar system either smash into something, are drawn into orbit around the sun, or get thrown back out into space. The sun's gravity can only influence the route of the 3I Atlas a little bit because it is moving so quickly. Scientists say that it will move through our solar system on a hyperbolic trajectory and then go back out into interstellar space. This will happen unless someone modifies its direction on purpose. It is really hard to understand when you think about how big this monster is. Initial measurements indicated that the 3I Atlas might span 6 to 9 kilometers in width. That's about the same size as Manhattan Island. Take a time to think about that. We're not talking about a tiny piece of ice or rock. We're talking about something the size of a whole metropolis hurtling across space at speeds that are hard to understand. The fact that 3I Atlas is this big makes it really different from anything else we've seen. Scientists were startled by the strange things about Oumuamua, the first confirmed interstellar visitor, when it traveled through our solar system in 2017. It was thought that Oumuamua was about 330 to 380 feet long, which is about the same length as a football field. That was previously thought to be very big for an object in space. But 3I Atlas is hundreds of times bigger than Oumuamua. Oumuamua would look like a small stone next to a big building if you put them next to each other. The combination of size and speed poses important problems that are hard to address. Space's natural processes can definitely make big things. There are asteroids, comets, and even minor planets all around our galaxy. But moving anything this big to such high speeds, and keeping it intact over interstellar distances, involves forces that are quite unusual in nature. Most of the rocks and ice chunks that get thrown out of their home solar systems are far smaller. They are usually only a few hundred or thousand feet across, not miles. Avi Loeb, a professor at Harvard University, looked at all the information regarding 3I Atlas and came to a conclusion that shocked the scientific community. Loeb and his research team say that this thing might not be natural at all. Instead, we might be seeing the first time that people have definitely come into contact with technology made by an intelligent alien species. If this theory is true, then something from another star system has been moving through space for a very long time, maybe even to study our solar system, and maybe even our planet. Loeb doesn't usually make outrageous allegations without proof. He is a well-known astrophysicist who has written hundreds of peer-reviewed publications and was the head of Harvard's astronomy department. Some of his co-workers are uncomfortable with how open he is to the idea of alien technology, but he says that scientists have a duty to look at all possible explanations for strange observations, even if those explanations go against what we think we know about our place in the universe. The potential artificiality of 3I Atlas poses unprecedented inquiries for humanity. What was the function of this thing if an advanced culture made it? Are they just interested in other worlds and doing a big survey of the galaxy, or could there be more troubling reasons for such a mission? We don't have a way to grasp what an intelligence that could build something this big and send it on a voyage that lasts thousands of years wants. The discovery of 3I Atlas is a turning point in human history, even if it turns out to be purely natural. We can investigate something that came from another star system for the first time. It may have developed in settings that are very different from those in our own cosmic neighborhood. Every measurement, observation, and piece of data we get about this visitor gives us information about parts of the galaxy that we can't get to in any other way. The arrival of the object also shows how little we still know about the universe around us. Before 2017, we have never seen any interstellar objects pass through our solar system for sure. In less than 10 years, we've found 3 of these visits. This makes it seem like there are a lot more wandering objects in interstellar space than we thought before. There may be dozens or perhaps hundreds of these passengers passing through our solar system every year. Most of them are too small or too dark for our telescopes to see. There are many good things about the date of 3I Atlas's discovery. Astronomers were able to plan extensive observation campaigns for 3I Atlas since they saw it coming well in advance. This is different from Oumuamua, which was only seen as it was departing our solar system. Telescopes all over the world have been following its movement and gathering information about its surface features, composition, and any changes in its behavior as it moves through different parts of our solar system. Scientists now have a unique chance to test hypotheses about interstellar objects and maybe even address some of the questions that came up during Oumuamua's short stay, thanks to this longer observation time. Every night that 3I Atlas is still visible gives us another chance to collect information that could change our ideas about what is out there in the voids between stars and how these things act when they come across planetary systems. Like ours, 3I Atlas is so big that it makes us question everything we thought we knew about how things move across space between stars. When astronomers initially figured out its real size, a lot of them checked their tools and did the math again. It seemed like the measures were unachievable. We're talking about an object that is so heavy that it makes it hard to understand how it might be heavier than any other interstellar visitor we've seen. To really comprehend what makes 3I Atlas so special, we need to know how physics works when you move something this big at such high speeds. Things can keep going at the same speed forever once they're put in motion in space, since there's no air resistance to slow them down. But it takes a lot of energy to get them going that fast in the first place. To speed up an object, you require more force the bigger and heavier it is. Look at it this way. You'd need a certain level of force to toss a baseball over a field. But if you wanted to toss a car the same distance at the same speed, you'd need a lot more power. Now picture trying to speed up something the size of Manhattan to speeds that would let it travel the distance between Earth and the Moon in only a few hours. It's almost impossible to figure out how much energy is needed. These kinds of tremendous speeds can happen naturally, but they are quite rare and usually happen during cataclysmic cosmic occurrences. For example, a supernova explosion can send things flying out at very high speeds. Gravitational interactions can also throw things across space when they get too close to huge things like black holes or neutron stars. But most of these processes tend to break things apart instead of keeping them whole. The forces are so strong that rocks break, ice turns into gas, and anything that isn't kept together by a lot of internal power gets torn apart. This is why 3I Atlas is so hard to understand. It's not just huge and going very quickly, but it also seems to be holding together despite the forces it must have felt on its way. Whatever sent this item into interstellar space, whether it was natural or man-made, must have done so in a way that kept its structure intact over distances of light years and time spans of thousands of years. The speed of 3I Atlas also gives us important information about where it came from. Scientists can figure out where an object in space came from and what changed its direction by looking at its trajectory. The figures for 3I Atlas show that this item arrived from outside our solar system with what is known as excess hyperbolic velocity. This means that as it got close to the Sun, it was already going faster than the speed of escape. Things that form in our solar system move in regular elliptical orbits around the Sun. Comets that come from the faraway Oort cloud could take thousands of years to do one full orbit, yet they always return back. Asteroids in the main belt between Mars and Jupiter move in a way that is as regular as clockwork. Comets that dive close to the Sun and then swing back out into the outer solar system are still held by the Sun's gravity. The 3I Atlas, on the other hand, is distinct. Astronomers term it gravitationally unbound, which means it will only travel through our solar system once and never come back. This hyperbolic path makes a parabolic arc through our cosmic neighborhood. The object comes from deep space, will pass by a few planets in our solar system, and then go back out into the galaxy. The Sun's gravity will change the direction of this visitor, but it won't be able to catch it. The speed is just too high. It's like attempting to catch a bullet with your hand. The object is moving so quickly that gravity doesn't have time to bring it into orbit before it moves away again. When you think about the energy involved, the physics of this gets much more interesting. The energy of motion, or kinetic energy, goes up with the square of the speed. This means that if you twice the speed of something, its kinetic energy doesn't just double, it quadruples. Even if two objects are the same size and weight, one moving at 130,000 miles per hour has a lot more kinetic energy than one moving at 65,000 miles per hour. The total kinetic energy is mind-boggling for something as big as 3I Atlas that moves so fast. If 3I Atlas hit a planet, the damage would be unimaginable. The amount of energy released would be much bigger than anything humans have ever seen. The asteroid that killed the dinosaurs 66 million years ago hit Earth at a speed of about 45,000 miles per hour. It was also a lot smaller than the 3I Atlas. That impact let forth energy equal to billions of nuclear bombs and impacted the course of life on Earth. A 3I Atlas-sized object going almost 3 times as quickly would give off a lot more energy. Luckily, its path doesn't take it anywhere near a collision track with Earth or any other planet. Another interesting thing to think about is the temperature of 3I Atlas as it was traveling. In the depths of interstellar space, far from any star, the temperature is only a few degrees above absolute zero. That's almost 270 degrees Celsius below zero or 454 degrees Fahrenheit below zero. Most things get very fragile at these temperatures. Ice gets harder than steel. Like glass, metals may break. To make it through its voyage without breaking, 3I Atlas must be made of materials that can handle the cold of space, as well as the heat stress of going from the chilly emptiness between stars to the warmer space closer to the sun. As 3I Atlas travels through our solar system, it is getting warmer from the sun's rays. In an atmosphere, the sun's heat moves through space by conduction or convection. Instead, it sends forth electromagnetic radiation in all directions. When an item gets closer to the sun, it gets more of solar radiation and gets hotter. This heat usually makes ice and rock objects let out gas. The tail that comets have is caused by water ice turning directly into vapor. But early observations of 3I Atlas didn't show the kind of outgassing activity that would be expected from a comet of this magnitude. Professor Loeb was interested in this because there wasn't much outgassing. When natural frozen bodies come in from the cold of interstellar space and get close to the sun, they should show a lot of activity as they warm up. The fact that 3I Atlas didn't seem to be moving much made it seem like it was either built of material that could handle the heat of the sun better, or that it wasn't a natural item at all. Some experts think it might be mostly rock instead of ice, which would explain why it doesn't outgas. But the fact that rocky objects this big are being thrown out of their home, solar systems, at such high speeds, makes natural formation theories even harder to explain. The fact that 3I Atlas seems to be spinning, or not spinning at all, adds to the enigma. Most things in space spin, and they do so very quickly most of the time. This rotation generally happens because of the forces that made them, or because they ran into other things. When asteroids hit each other, they spin. Conservation of angular momentum says that when things come together to make a new object, it almost always spins. But early observations indicated that 3I Atlas may not be rotating considerably, or if it is, the rotation is exceptionally slow and stable. It's not common for something this big to not rotate or to rotate slowly. It implies that the object was created under highly particular conditions that led to negligible rotation, or that an external force has been maintaining its stability. Stabilization would make sense for something that isn't real. Gyroscopes or thrusters could help a spacecraft or probe stay in a certain position. It seems unlikely, but not impossible, that a natural object could stay so stable after traveling across space for millions of years, passing through areas with different gravitational effects and maybe even running into other things along the way. Astronomers maintained an eye on 3I Atlas through their telescopes, and they started to see something that made even the most dubious scientists stop and think about what they thought they knew. It wasn't random or chaotic as you'd anticipate from a piece of space junk. This item was on a set journey across our solar system. Instead, it looked like it was following a trajectory that was nearly perfectly tuned to bring it within sight of several big planets in a sequence that seemed to be planned. It looks like the person who planned the trip wanted to see as many cool places as possible, while using as little gas as possible. In October, 3I Atlas will get within around 17.5 million miles of Mars, which is rather near. That might sound like a huge distance, and it is by Earth standards, but in astronomical terms, this is what scientists call a near approach. An advanced observation system would be able to gather a lot of information about Mars, its atmosphere, its surface features, and maybe even pick up traces of human activity from our rovers and landers on the surface at that distance. The item is still moving toward Earth from Mars. It will come closest to Earth on December 19th, when it will be around 167 million miles away. This is a lot farther away than the Mars encounter, which has confused some scientists. If the purpose was to study Earth, why not get closer? After passing Earth, 3I Atlas will swing past Venus at a distance of around 60 million miles. Then it will fly back out into the outer solar system to meet Jupiter one last time, this time at a distance of about 33 million miles from the gas giant. The results were shocking when scientists figured out the statistical chance of such a path happening on its own. They figured out that the chances of an interstellar object randomly pursuing a path that puts it close to 4 main planets in such an orderly and effective way are very low. The chance was less than 0.005%. To put it another way, if you sent 20,000 objects into our solar system from random directions and speeds, only one of them would naturally follow a path that is even close to what 3I Atlas is doing. This unlikely statistic doesn't prove anything for sure, but it does raise some good questions. Are we seeing a really uncommon cosmic coincidence, like something that happens just once in tens of thousands of interstellar object passages? Or are we witnessing something that was intentionally orchestrated by an intelligence proficient in calculating trajectories across interstellar distances with exceptional accuracy? The artificial theory has been most strongly supported by Professor Avi Loeb. His logic goes beyond only the path. He says that the mix of elements we're seeing with 3I Atlas is getting harder and harder to explain only by natural processes. Loeb thinks that the size, speed, trajectory, lack of considerable outgassing, and stable motion all add up to a picture that makes people think about non-natural origins. Loeb has received a lot of flack from other astronomers for being open to talking about the potential of alien technology. A lot of experts think that extraordinary claims need extraordinary evidence, and the current information about 3I Atlas, while strange, doesn't satisfy that standard. They say that we should look at all the natural explanations before we assume that there is intelligent life outside of Earth. Dr. Michelle Bannister, an astronomer who studies tiny bodies in the outer solar system, is one of Loeb's most vociferous critics. Bannister says that 3I Atlas is definitely strange, but strange doesn't necessarily fake. The universe is very big and very old, and strange things do happen. Just because something is unlikely doesn't imply it can't happen on its own. She says that if we only saw occurrences with a high chance of happening, we would never learn anything new about the cosmos. Other scientists have come up with different reasons for why the item is moving in such a strange way. Some people think that 3I Atlas may have gotten help from gravity, from things we can't easily see, like rogue planets or brown dwarfs that are moving across space between stars. These gravitational interactions may have changed its course in ways that look planned, but were really the product of random meetings over millions of years of journey. The discussion about 3I Atlas has also brought up Oumuamua, the first interstellar visitor, which has its own strange traits. As Oumuamua departed our solar system, it sped up a little bit. This behavior couldn't be entirely explained by solar radiation pressure or outgassing. Loeb and other academics have said that this acceleration might be a sign of some kind of propulsion system. Some people thought that Oumuamua might be formed of solid hydrogen, which might explain both its strange shape and the fact that it sped up due to outgassing that we couldn't see in our observations. The problem with researching these guests from other stars is that we don't have much time to see them, and we have to do it from a long way away with tools that, while advanced, have their limits. We're attempting to figure out things that are millions of miles distant and moving very quickly, and we only get one shot to collect data. At least with the technology we have now, there are no do-overs or chances to send a probe for a closer look. The fact that 3I Atlas will approach Earth when it is on the other side of the Sun from our point of view is what makes the timing so vexing for scientists. This means that when the object is closest to Earth, the Sun will be squarely between us and the object. This will make it very hard, if not impossible, to see it well with ground-based telescopes. The Sun's glare would drown out any signal from 3I Atlas, making our most powerful instruments blind at the exact moment when we would want to see the object up close the most. Some researchers find this timing strange, as if the item is trying to escape being closely watched. This is exactly how you might plan a reconnaissance expedition to examine a solar system while lowering the risk of being studied in return. You would get close enough to the inhabited planet to get vital information, but you would plan your closest approach for a moment when the planet's residents couldn't easily see you. However, doubters say that this view means we have to presume that whoever or whatever sent 3I Atlas would know where Earth was in its orbit when it got close. This is plausible for a really evolved society with a lot of astronomical data, but it requires giving them a level of planning and understanding that we can't truly show with the evidence we have. Also, why would an intelligent culture send something this big to spy on them? If the only purpose is to get information, smaller probes would work much better. They would be easier to speed up, need less energy to launch, and be less likely to be seen by the civilization being watched. For a simple mission to gather information, an object the size of Manhattan seems like too much, unless the size has some other purpose we don't know about. Some scientists think that the 3I Atlas might be an old piece of technology, like a probe or ship that was sent out millions of years ago by a civilization that may not even exist anymore. If it has been traveling through space for a long time, its huge size may have been needed to make sure that enough of the craft made it through the trip without breaking. Cosmic rays, micrometeorite strikes, and the slow erosion of interstellar dust particles would be more likely to hurt smaller things on a journey that lasted millions of years. Some people think that 3I Atlas could be a piece of a much bigger structure that broke off at some point in its past. It could have been part of a huge spaceship or space station that broke down in a big way, or it could be a chunk of a planet that was destroyed when two stars collided or was sucked up by a black hole. In this case, what we're seeing isn't a planned mission but a piece of space junk that has been floating around the galaxy for a very long time. The fact that 3I Atlas passes Earth at a distance of around 167 million miles has also been a topic of dispute in the argument concerning what it is. That's more than the distance from the Sun to Earth, which is around 93 million miles. If this were indeed an alien probe meant to examine human civilization in depth, it seems strange that it would come this close yet not any closer. Telescopes on Earth now can see things at this distance, but it would be far easier to get high-resolution information on a civilization's technology, culture, and talents from a much closer distance. Astronomers all across the world agree on one thing about 3I Atlas: no matter what it turns out to be, it is either a natural event or something more unusual. This finding is truly extraordinary in the entire history of human study of the cosmos. The name of the object itself informs us how unusual and valuable this chance is to learn more about the universe outside of our solar system. The number 3 in the name means that this is only the third interstellar object that we have found and confirmed since we started looking for visitors from other star systems. The letter I stands for interstellar, which means that these objects are very different from the millions of asteroids, comets, and other debris that are in our own solar system and follow predictable paths around our sun. Confirmed interstellar visitors are so rare that each one is a unique scientific treasure that gives us information about parts of the galaxy that we would never be able to study otherwise. Oumuamua, the first interstellar visitor, came in 2017 and surprised most astronomers. The asteroid was already moving away from our solar system by the time scientists figured out what they were looking at and started planning large-scale observation programs. It was too far away and too faint for the instruments we had to use to look at it closely. Researchers were frustrated because they realized they were watching a once-in-a-lifetime chance slip away. Oumuamua had been traveling across interstellar space for millions of years, but it only took a few weeks to pass through our solar system as we tried to gather as much data as we could. The astronomy community learned a lot about how to prepare and respond from that wasted chance. Astronomers were better ready when the second verified interstellar visitor showed up in 2019. Researchers had months to plan detailed observation campaigns since they found Comet 2I Borisov far earlier in its passage through our solar system. Borisov was tracked by several telescopes all over the world, which gathered information about its structure, composition, and behavior, but Borisov acted a lot like comets that are close to us in space. It had a tail of gas and dust behind it that was visible, which is a common feature of comets. The sun's rays warmed its frozen surface. Borisov gave us useful comparison data that showed how comets can develop in other star systems in the same way they do in ours. However, it didn't provide the same basic mysteries and problems to our knowledge that Oumuamua did. 3I Atlas is very distinct from its two predecessors, which makes it very useful for expanding human knowledge. Because it is so big, it will stay visible and trackable for far longer than smaller things. This allows astronomers more time to look into its makeup, how it acts, and any changes that might happen as it moves through different parts of our solar system and interacts with solar radiation and gravity. For a few weeks, you could see Oumuamua, and for a few months, you could see Borisov. Depending on how its brightness changes as it goes away from the sun, 3I Atlas may be monitored for a year or more. The strange path that 3I Atlas takes to get close to several planets lets people see it from varied angles, distances, and lighting conditions. Every time this strange visitor comes into contact with a planet, it could show us something new about it that we couldn't see before. The angle at which sunlight hits the object's surface varies as it passes through our solar system. This could show features or differences in composition that weren't evident before. The timing of the discovery of 3I Atlas has also been scientifically lucky in ways that other interstellar objects weren't. Astronomers saw it coming months in advance, giving them time to plan what could be the biggest observation campaign in the history of astronomy. We have used ground-based telescopes, space-based instrumentation, and levels of international cooperation and data sharing that have never been seen before to examine this visitor. Research teams from many nations are working together to make sure that every chance to collect data is used. Some of the most ambitious and technologically difficult space missions ever planned by human engineers and scientists have been inspired by the frustration of watching Oumuamua vanish into interstellar space before it could be adequately explored. These projects show that people are determined to never again be caught off guard by strange visitors from distant star systems, whether they are natural events or something more unusual. Project Lyra is the most ambitious of these proposed missions. It was originally meant to track down Oumuamua, but it is now being changed to catch future interstellar visitors, possibly even 3I Atlas itself, if its behavior has to be looked at more closely. To catch up with things moving at such high speeds, we need to make huge improvements in propulsion technology, spacecraft architecture, and mission planning that go well beyond what people can do right now. Engineers working on Project Lyra have come up with a number of ways to reach the very high speeds needed for interstellar intercept operations to be effective. The best method is to use the gravity of several planets in a precisely planned sequence. This would turn our whole solar system into a huge cosmic acceleration system. A spacecraft might pick up a lot of speed at each planet it passes by making very fine modifications to its trajectory, just like a pinball picks up speed by bouncing between bumpers. A normal Project Lyra mission might start with a launch from Earth and a direct flight to Venus for an initial boost from Venus's gravity. Then, the spacecraft would return to Earth for more acceleration from Earth's gravity well, and finally, it would fly to Jupiter, where the gas giant's huge gravitational field would give it the final push it needs to reach speeds close to or even higher than those of the interstellar targets it is looking for. Computer models show that this kind of complicated orbital choreography could speed up specially designed probes to speeds close to 74,000 miles per hour under the best conditions. If more unusual mission profiles that involved getting very close to the Sun were successful, they might even be able to reach speeds of 163,000 miles per hour. The European Space Agency is taking a very different approach with their Comet Interceptor mission, which is set to launch in 2029. This new idea doesn't involve trying to catch things that have already been seen and are speeding away from our solar system. Instead, it involves placing a high-tech spacecraft in a strategic spot in space, where it can wait for the next interstellar visitor to show up and then quickly deploy to catch it during its approach phase, when it would be easiest to study it in detail. This waiting technique is based on the fact that we now know that interstellar objects pass through our solar system more often than we used to think. This makes it possible to put a probe in place for an encounter that will happen someday.